Okay, for geocoding, we will learn, get an overview for the geocoding process and using zip codes and geocode addresses, using streets, using alias tables for place name geocoding. Although much available data is already geocoded, in many situations we will find data in a table that we want to plot on the map. One example is the survey data from here that lists street addresses, zip codes, and the home states of the people surveyed. Using these location attributes, we can map geocode the location. Another example is transaction data collected by organizations, and perhaps we are working for such an organization because transactions such as delivery of an appliance often occur at a location. It is useful to map these locations to analyze the market served. Another example for transactions is survey patients in a hospital. In this case, it is useful to map the residences of patients to identify the service area of the hospital. So a geocode is data that identifies a unique location, a point, line, or a polygon on planet Earth. For example, the geocode 4800 Forbes Avenue, Pittsburgh, Pennsylvania 15213 identifies a unique point. The zip code 15213 is also a geocode identifying a unique polygon, and Pittsburgh, Pennsylvania is a geocode identifying a unique county subdivision polygon. If we have such source data, we can use ArcGIS-Pro's geocoding algorithm to map corresponding points by matching to reference data. Reference data is a feature class with existing locations, for example, street center lines with street address attributes, or zip code polygons with a zip code attribute. So the source data that we will geocode in the beginning of this session is from a survey that includes residence addresses of attendees taken by an arts organization for its annual art show. The art organization wants to analyze locations of attendees to better target future marketing efforts. So we will first geocode by zip code only, and then by street addresses. So that we will do is streets and geocode. And GIS Online have a typed addresses with notes, including in address fields such as 3300 Pine Avenue. Watch out for vicious dog. Wow, that's really crazy. Vicious dog. Okay, the ArcGIS Online one. We have the problem solving. Let's see, ArcGIS Online. Okay, online geocoding. I don't remember if I did the ArcGIS Online one, and that makes geocoding a challenge. Consequently, exactly matching of source to reference data is not possible. Instead, we must use fuzzy matching. Fuzzy matching, a kind of matching used in computer science to make matches that are approximately instead of 100% accurate. It mentioned here. Fuzzy machine matching. Okay. And then for example, the address 123 Fleet Street. Fleet Street, okay, may be on a map, and a data entry worker may have a typed 123 FLEAT. For the source data with a misspelling without the ST, a fuzzy machine algorithm might determine that address is close enough to the correct address and plot the residents of 123 Fleet Street. A rule-based expert software system can make fuzzy machine. ArcGIS Pro geocoding software is such a system. The system attempts to use the thought processes and rule that an expert would use to accomplish a complex and ambiguous task. So in this case, the expert system attempts to mimic what a resourceful mail delivery person would do, using their expert knowledge to get a badly addressed piece of mail to the right address. So the following expert system components are used in ArcGIS Pro geocoding: source table with attributes of location include geocode. To be mapped, reference data which has mapped features such as street, center lines, or zip code polygons, and attributes such as street names that can be matched fuzzily to the source table's geocodes. Okay, geocoding tool with the algorithms, rules, users interface to perform geocoding. Locator, a usable set of 3 or more files that include all parameter values of the tool that performs geocoding for a given kind of source data. So to account for spelling errors, an algorithm computer is a soundex key, which is a code assigned to names and that sounds like, for example, flea and flea. Both have soundex key F43 and identifies candidates matches on the basis of matching source and references street address lookup soundex key in the web search engine. The algorithm starts with a score of 100 for each case and subtracts penalty points for each problem encountered. In the end score is greater than the threshold set. As a parameter by default or by the user, a reference location is a candidate for matching. The candidate with the maximum score is chosen as the estimated location. If there is a tie, one of the trying locations is arbitrarily assigned as the match unless the user chooses to not accept ties, 50% of which are incorrect. We can geocode with any number of data types. For this, we will geocode using street, center lines, and zip codes. People generally will disclose their zip codes in surveys and get them right, so the results are complete and accurate, albeit only at the zip code level. You can download a U.S. Census Bureau zip code map for the entire United States for geocoding nationwide. Often, a zip code may be the only available data type and will service for marketing purposes, service, product delivery, and other location-based needs require more precise locations. Street central lines are sufficient for many purposes, but certainly not for locating in-ground natural gas and other lines during construction digging. You can easily use geocode with the zip codes and street central lines with free map layers downloaded from the internet. And however, cities and states perform many other kinds of geocoding, often more precisely using land puzzle centroids with street addresses provided by many city governments. Note that Esri provides the highly accurate and current ArcGIS Online World Geocoding service. And if we are in class and however, check with your which person that you use the service, because using the service consumes credits that must be purchased. We will have to see what version I have. And dual range maps. So dual range map available from the Census Bureau, Tiger Line data, and from vendors are widely used for geocoding, but are limited by only having house numbers on the left and right for the beginning and end of each 1 block long street segment. Consequently, addresses within blocks are linearly interpolated. For example, 150 Main Street is plotted halfway along the street segments with ranges 100 to 198 and 101 to 199 and are not exact locations. Generally, not all source data records are matched when geocoding. A performance measure for geocoding is the percentage of source addresses that get matched and plotted using the reference data. To compute match rates, we should subtract all records in source data that are not addresses. Records that are blank, do not start with a house number, are not street intersections, and so on from the total number of addresses in the source data uses in the denominator for the match rate. Unfortunately, there is no way to judge if a match is truly correct. Organizations that critically depend on geocoding, such as 911 emergency calls for services from police, fire, and ambulance responders, review non-matches and incorrect matches to improve their maps and produce procedures for obtaining correct source data from callers. The sensitivity analysis in assignments 8.3 on the book, here we will talk about it, will offer some insights into match accuracy. So we will choose house threshold in matching rules, changeable through two parameters, until matched addresses added to previously matched addresses are identified clearly as errors. In general, the default settings for locator files perform well in the sensitivity analysis. So for geocoding, we will geocode survey data collected by a Pittsburgh arts organization that holds an event each year, attended from across the 3 states region, Pennsylvania, Ohio, Maryland, and beyond. We will save space on the computer hard drive. Following exercise, we will use the zip code polygon from the 3 states mentioned plus West Virginia, the relevant region of Pittsburgh, instead of the entire country, which takes 2.5 gigabytes of disk space for zip codes. Alright, so we introduced the topic and we will get started. Okay, so the example that we mentioned everything previously, and linear geocoding, that's an interesting, and we will get into detail in address components that we will talk about it, and how to set intersections, and geocoding flow, match and non-match, and how to look at some of the steps. And sound X, we mentioned that, and we will get into detail, and then we will come back to review. Just remind me, I will come back to review everything. Spatially joined to those block groups and problem and solution. So for the problem and problems, we have we already mentioned variations in street names and data entry errors like the fleet and place names and same street in multiple zones, and you will have a lot of things that repeats. For example, you have a Washington Street almost in every city. And some possible problems and missing street data. There are some solutions to it. Clean data before geocoding, purchase or building high quality maps. Oh, those will be expensive. Because you need people to go out into the field and collect them, and people will change them. So that's how the crowdsourcing is in. You use the volunteer people. People will contribute to some of the data. And prepare log file. Log file includes reasons why address did not get geocoded, useful for future work on cleaning addresses or repairing street maps. And we also have some geocoding source. We mentioned that we have a US Census, Tiger Fire, and Tiger Linear Attribute Table. And the Tiger Fire that we will use, and we will come back and get a lot into detail, and the pros and cons for local jurisdictions, and we will go over all these. Okay, and online geocoding could be interesting, but there are a lot of things we have to think about. All right. So now we will continue to our folder. So we will start with Chapter 8, Exercise 1.